Welcome. Today we're going to discuss a very important topic in programming called iteration, or looping, kind of informally the way it's called. What we're going to see is that in many applications, it's necessary to perform the same operation many different times. Rather than duplicating code, we can control the process by creating what is called a loop. We'll be looking at two structures for performing loop operations or controlling loop operations. One is called a while loop and the other is called a do while. There are some similarities, but there are also some important differences between these two structures. Now we'll be using Java to illustrate the ideas, but keep in mind that when you're programming, concepts such as iterative processing or sequential processing, conditional processing, these concepts all apply to all programming languages. It's not something unique to Java. We're simply using Java to illustrate these concepts. So let's give you a little background and then we'll provide some examples to demonstrate how this actually works. When writing a program or implementing any kind of algorithm, there are three basic structures that we'll see present in most programming languages. And these would be the simple sequence, the selection, and the iteration. These control structures allow us to dictate the flow of control or the activity that's going to occur within a program when it executes. In the case of the simple sequence, we're simply performing one operation after another, executing the instructions as they're listed or as we encounter them in the order in which they're presented within the program. Consider as an example doing something like opening a door. We'll extend our arm, grasp the doorknob, turn the doorknob, pull the door, and it's open. Simply executing those instructions in order. And very often this is done one time, but we'll see that this sequence of operations can be used in conjunction with the other control structures. The selection or choice type of operation is where we make a decision. In our flowchart here, the diamond indicates some kind of a question that's being asked, a decision that's being made. So say, for example, you were a service person making some kind of a house call. So you'll come to the door and you'll say, hey, there's a doorbell. And you'll say, if there's a doorbell, ring the doorbell. Else, knock on the door. That's where we're making a decision and taking two different actions based upon the result of that evaluation or the decision result. Finally, we get to the focus of this video where we're looking at some statement or block of statements that we wish to execute many times. But at some point, we want to terminate this processing. So there is a conditional aspect to this, but the point is there's a block of code that we're going to execute multiple times. With the simple selection, we made a decision and did one thing or did another thing and then moved on. But in the case of iteration, we're going to make some kind of a decision and do something, perform that decision or ask that question again and then do something. And we may do this many, many times. So let's take a look at loop control structures available in the Java programming language. Java provides three types of loop control structures. One is the while loop, another is a do while, and a third, which we're not going to be addressing specifically in this video, is called a for loop. The first two are considered logically controlled because we're basing the determination of whether to repeat the execution of a sequence of operations by testing some kind of a condition. There's some test that's being performed against what's called a control variable. With the for loop, this is said to be a counter-controlled loop. There is a control variable, but the control variable is actually an integer that's used to determine the number of times that the loop will be executed. We'll have more to say on that in some future video. But let's focus now on the while and the do while. With a while statement, we've given a flowchart here to give you a feel for how the logic is employed. Notice that what we do prior to entering the body of the loop is to perform some kind of a test. This is the condition that's evaluated, and the evaluation is going to say true or false. And if it's true, we then execute the body of the loop. So the test evaluates some kind of a Boolean expression. For example, is there a doorbell? That's going to be true. There is a doorbell, or it's going to be false. There is not a doorbell. So the test is done before we execute the body of the loop. We don't just jump in and start executing instructions that constitute the body, but what we do is we perform the test beforehand. Hence, a while structure is sometimes referred to as a pre-test control structure or a pre-test loop, because we perform the test before we enter the body of the loop and execute those instructions. The body of the loop could consist of a single statement, but typically it consists of multiple statements, what we'll call a block structure or a compound statement. And again, in Java syntax, that would be a series of simple statements enclosed within the curly braces to have them treated as a unit. In addition, the body of the loop executes only when the test evaluates to true. When the test evaluates to false, we no longer go into the body. This has the implication that the body of the loop might execute 0 or more times. We might not execute it at all because we performed the test prior to entering the body at all. So if the test fails or returns a false, we don't execute the body at all. It's simply the nature of a pretest. There's also something we've got to be concerned with, going back, say, to the body of the loop. We want to avoid a loop that never ends, something called an infinite loop. So we have to make sure that eventually, when that test is conducted, that it will evaluate to false. And the way we do this is by performing some operation within the body of the loop that will cause the condition to be evaluated as false. Remember, it was evaluated as true, otherwise we wouldn't be executing instructions within the body. So we have to cause the condition to change at some point. Otherwise, we'll be in the loop for a long, long time. Consider years ago, manufacturers of shampoo used to put on the bottle some directions for using the shampoo. And these directions simply said lather, rinse, and repeat. So if you follow those instructions directly, you're doing an infinite loop. It never says to stop. It just says lather, rinse, do it again. Lather, rinse, do it again. So the point is we want to avoid such situations in our programs. Now, the notion of a compound statement is something I briefly reminded you about. This is sometimes called a block statement, and we enclose a group of statements to be treated as a unit, kind of treated as though it's just one statement, but in reality it consists of multiple simple statements combined together or grouped together, and syntactically we group these together by enclosing these statements within a set of curly braces. And typically this is what we're going to see for the body of a loop, because we're going to perform some operation, and we also want to do something that can cause that condition to ultimately evaluate to false. The general syntax of a while statement is summarized here. Again, this being a pretest, we say while, and here's the condition or the test that we're performing. This is either going to evaluate to true or to false. If it evaluates to true, we go in and do the body of the loop. When we complete the execution of the body of the loop, or that iteration, we kind of come back up to the top and perform that test again. We evaluate the condition again. Provided it remains true, we'll execute the body again, come back up, test it again. And this is why it's important to cause that condition ultimately to become false and avoid, say, an infinite loop. Now, we need to perform some kind of priming operation, as I indicate in my final comment on this slide. That means whatever condition is being evaluated, we have to set some value of a variable that perhaps is being tested as part of that condition prior to encountering this while structure. So that means something is going to be done before the while statement in order to cause the condition to be evaluated, either true or false. And this is some kind of a priming operation. Here's a simple example where we have a variable called number, which is declared to be of type integer. we assign a value of 1 to the number. This is the priming operation. We get number ready to be tested. Then the while statement starts off by saying, let's look at the value of number. If the value of number is less than or equal to 5, then we'll go in and print out the message hello. And very important, we'll change the value of number prior to completing this iteration of the body of the loop. We then go back up to the while condition that we stated, and now we look at number. Is it still less than or equal to 5? If it is, we do the print and the increment, and we continue to do that until number has a value that's greater than 5. Or I should say, while number has a value that is not less than or equal to 5. That is, number is greater than 5. Then we'll skip the body and finally execute the print line statement indicated at the bottom of the display here that prints out the message goodbye. Let's take a look at this code in action. We'll go into an IDE and run the code and play around with it a little bit. Here we see a complete application with the code that we've been discussing for the while loop embedded within the main method. So we put a little message out to tell you what we're doing, and then we initialize our control variable, and we conduct the test. Is the control variable less than or equal to 5? If that is true, that's our control condition. Then we enter the body of the loop, print out the message hello, and just to show you as we go through the loop how many times we've gone through, we also append the value of the number, whatever that might be. Then we change the value of the number, change the control variable, come back up and do the test again. Provided the test evaluates to true, we enter the body and repeat that process. Eventually, we should get a value in number that will cause this expression to evaluate to false, and we'll fall through and print out the goodbye message. Well, let's go ahead and fire this up and see what it produces for output. We see the message running the while loop, and we see hello coming out 5 times, each time with the variable of number appended to it. So we have 1, 2, 3, 4, 5. It became 6, and when we go back up and look at this, 6 less than or equal to 5 is not a true condition. Therefore, we fell through to line 17 and executed the display of goodbye. Let's make a minor change to this code and change the initialization process here, where we're going to assign a value of 6. We'll compile the code and give this a try. So now, outside of the loop, we do our preparation and we assign a value of 6. What happens? Well, now 6 is the value in number. 6 less than or equal to 5 is not true, so we don't enter the body. We simply come down and print the goodbye message. So again, this is the notion of the pretest. The body could be executed 0 or more times. Take a look at our other control structure, the do-while statement. Here we present the flow chart to depict the logic for this type of a loop. And let's discuss this a little bit. What we see is there is a test that evaluates as a Boolean expression. So it's going to yield a true or a false. But the placement of the test within the structure is quite different. This is done after we've executed the body at least one time. So we execute the body, then we perform the test. This is what's called a post-test loop. The body of the loop can again be a simple or complex statement, so it can consist of many statements grouped together. And the body is going to execute at least once. So the differences we're observing just in discussing the structure would be that it is a post-test versus pre-test. The test is conducted after executing the body. And furthermore, with the while, the body is executed possibly 0 times, never executed. While with the do while, it's always executed at least once. Here's an example using some similar processing to what we illustrated with the while structure. We again initialize our variable outside of the loop structure, kind of a priming operation. Then we proceed to perform the operations indicated within the body. Again, we're going to give our control variable the option of causing the condition to evaluate to false, so we're going to change it, again incrementing it here. But notice the test is coded at the bottom. Number, again, being tested for less than or equal to 5. As long as this is true, we'll go back up and re-enter the body. And then finally, when it is no longer true, we'll exit the body and print out the goodbye. Let's take a look at this in action. Here we have the code for the do while. Take a closer look at this. Again, we have our priming operation to initialize the control variable. Then we have the word do, which precedes the body of the loop, and the body of the loop here is enclosed within the curly braces. Within the body, we simply put out the message hello. Appended to that will be the current value of the number variable, as we did in the previous example to demonstrate the while loop. In addition, we increment the value of the control variable. And then, because it's a post test, we conclude by conducting the actual control condition examination. We're going to test to see if number is less than or equal to 5. Provided this evaluates to true, we go back up and re-enter the body. Test it again, re-enter the body. Eventually, our expectation is, because we don't want an infinite loop, that this condition will evaluate to false and will fall through and perform the actual print of the goodbye message. So let's take a look at this in action by compiling this and running the code and see what we get. And here we see the output with our message telling us we're doing a do while loop. We see the value of hello with the current number, and finally the goodbye. As we did previously, let's make a change here to the control variable, give it a value of 6, and then compile and run this code. This time when we run it, notice we get the message running the do while, and then the message hello 6. Which means we entered the body and executed the instructions within the body. Although we may not have wanted to, because the condition is such that it's testing number to see that it is less than or equal to 5, and it's only when that is true that we want to go into the body. But because this is a post test, we always execute the content of the body at least once before we perform the test. So keep that in mind in comparing the two loop control structures in making a decision as to which structure is appropriate for your particular needs. In this video, we presented two control structures for dealing with iteration or loop processing. We looked at the while, which implements a pre-test type of structure, and we looked at the do while, which implements a post-test structure. Although we use Java to illustrate these concepts, we want to emphasize the importance of understanding while and do while, independent of any particular programming language. Our presentation covered the general operation of these structures, but we didn't really provide examples of how to use this in practice. In our next video, we'll continue our discussion of while and do while and look at things like input validation. We'll also look at something called a sentinel value for controlling the input coming in for a loop. So we'll see you next time and talk a little bit more about loop processing.